Hi guys, and welcome to yet another Devcast. Today it will be about an update that is coming to Instance Painter 0.8.0. This update is not out yet, but I wanted to do this Devcast because I'm hoping for a feedback on this new feature that is coming to the Instance Painter, which is a curve tool. It's another thing that I created, maybe some of you saw in my Machina framework, which is still in closed alpha, and it's a huge complex framework with visual scripting, similar to Houdini. But I'm porting some of these features as I see them to have a great value for Voxelizer or for the Instance Painter or even for Dash because it's node-based tool as well. So I decided to port this curve tool and implement it in a way that it's usable for the Instance Painter. So I will show you how it works. For now it's still in beta, so if if it crashes for some reason, it's because it's in the middle of implementation. So this is a new tool, so we can see it here up here next to the rectangle tool, and you can create curve. I can delete this one, which is by control picking points. So I can create a curve and I can position it as I want and so on. And if I want to paint instances based of this curve, I need to go to the instance painter editor window where you see the settings for the curve tool, and there are some main settings, which is the segment count, which is basically the amount of instances along the curve there will be. I will add later the distribution type, so it will try to distribute instances based on density or so on. So if you, for example, you have a longer curve, there will be automatically more instances instead of like specifying instances based on some arbitrary number and where the length of the curve is not taken into account. But for now, there is this segment count, so it may be renamed to instance count. Then there is the curve type, which is linear. We can also use Bezier curves. Bezier curves needs 4 points to at minimum because you have control points as well. So let's switch to back to linear. Then there is the distribution type, which is linear or uniform. This is based on how segmentation or how curve calculation works. So, for example, uh, if it's linear, there will be same amount of instances here and here, which is not really what we need sometimes because this is a shorter distance, but that's by basically a linear interpolation of the whole curve, how it works by default. So that's why I added distribution uniform, so it will distribute based on pre-interpolated distances, and this is the uniform precision, so it will automatically pre-interpolate. Even though linear curves are easy, Bezier curves are not that easy to calculate, so it pre pre pre-interpolates the distances and then use these distances to calculate the U, to normalize the U value for the correct instance distribution to have it in uniform way. Uniform is basically most of the time that you will need, but I'll leave the linear distribution type as well here. So let's switch it to uniform, and then let's paint. I have a single some kind of cube that is skewed in Y and Z direction, so it looks like a brick. And now it's painted along the curve. It's correctly rotated to the direction of the curve, and as you can see now, if the curve is longer, the 105 segments is not enough. So that's why why I said that the distribution will be there will be multiple ways how to distribute the amount of distances. So this is useful for example, for some kind of fancies and so on. But I wanted to bring something more, so I've decided to implement these features with the horizontal and vertical additional distribution of instances. So, for example, we can say that we want a additional vertical distribution along the curve. Let's bring a bricked wall, for example. So each next layer of the v count, which is a vertical count, will go up in the direction. So let's check it out. Let's check it out. It crashed on me, so I skipped the error. For now, I will fix it later. Okay, I found the issue. It's actually with modifiers that I will need to update for this new tool. Anyway, now it's as you can see, there are two bricks, two rows of bricks. So this is the offset. It automatically gets invalidated. The instances get invalidated if you change anything, any of the values in the curve tool. So we can play with it. There is an additional offset, which is the V curve offset, and it is an offset in the curve direction. So let's say we want an interlaced bricks, we can push it in this way. What this interlace curve offset does is that the first row is in this direction, the second row is in the another direction, and so on. So it will interlace the rows. You can see it if I increase this amount. So if it's just offsetted in a single direction, it will create this kind of like brick wall that's offsetted all to the left. So if I do interlacing, it will interlace, and even the corners will look better, and so on. There is additional modification that you can use. Let's boost this to 8, and that's using a V noise. It's using a parallel noise internally to basically noise this count parameter. So if I just enable it, you can see that the rows are not uniform, so it's not always 8 rows. It's actually maximum seems to be 4. So, and you can also scale the noise. So if I scale the noise, the parallel noise, if you worked with noises, you know how it looks. So if the amount that you do the scaling, it will be noised in a steeper manner. So if I go like 100, you see it's a very steep. So this value is high, and the next right to it is very low. That's because otherwise it's a curved type of noise if you're using parallel noise. But if you just do 100, it's like one pixel is 1, and the next pixel is 0, and so on. So you can work with maybe something. This is something you want, but for now I wanted something more like along these lines, and we can even boost this more. So this is how you can spawn a brick wall for some reason using this new curve tool. Additional things that come will be the minimum amount, the maximum amount as well. So the maximum amount is now by using the noise, but for example, what if I want just noise and I want to clamp it to at least 2 bricks? So that's things that need to be added. It's all about the UX and stuff that you probably want to use. This is why I am doing this Devcast, so you can tell me about other feature stuff that you would want, or a feedback that this is not really that usable for a specific thing that you want, or the UX is could be better, and so on. I'm all ears when it comes to good feedback. I can show you another thing, that is you can actually do, even though there is a specific horizontal stuff, you can do it in here because you can just change the offset, and you see that now it's distributed along the horizontal stuff. This is Something that you would probably want to do in horizontal later, because there will be a perpendicular vectors which are 2D vectors instead of 3D vectors, but for now, just for this demonstration purposes, it can be done in horizontal. You can also use the perpendicular offset, which will basically distribute these instances based on perpendicular offset. It's not just this offset, but it's rotated to a perpendicular vector to a direction of the curve. So it will be distributed like this. And you can also centerize this, which is uh, which is basically that it will be offsetted by the maximum amount of instances. Let me show you. It's better to see. If I use noise, this is how it looks because it's offsetted from here. But if I centerize the alignment of the offset, it will be offsetted to the middle. That's what I meant. So this, for example, this kind of distribution, I can even change the scaling. Let's do 4.8, and let's do rotation for some reason. And now if I invalidate the curve, you will see this is something. Let's do curve offset as well. So now this is something that can be used to distribute rocks along the road or along the curve. No problem. You can also use Bezier curve, as I said, to distribute rocks. If there is something else that you would want to see in this tooling, there is stuff that I was trying to implement, but it would need a programmatic pipeline of the distribution. Programmatic, I mean that for a user to be able to, something like in Machina, if you saw my Machina videos, you can actually create nodes that modify the attributes that goes through all this pipeline. So similar to what Houdini does in Vex. For example, the attribute wrangle node, where you can modify the positions in a way, in a custom way, using a Vex script or a C# in Machina. But there are definitely some things that I want to add, like this horizontal and vertical, that is very useful in general. And if I'm missing some things that can be set without injecting a custom code, basically, let me know. So also this obviously works with modifiers. As I mentioned, the modifiers are now a bit. Okay. There is a sphere modifier. If I go to the instances, it will automatically affect them. I need to enable that, obviously. So this is a sphere modifier, so you can affect them in a similar way, because these modifiers are decoupled from the tooling. Obviously, they work on the final rendered instances. So I will also, as I'm here in the 0.8.0 version, bring back the volume types of the modifiers, the UI for the modifiers, so because now you cannot see the modifier itself, it's a sphere. So as you know, during the refactoring of the 0.6 version, the colliders, custom colliders for modifiers are no longer available, because I simplified it for the refactor, and now I will bring the volume type for them back, so you can use rect, which is the one which is in the 0.7 version. Now there will be also a sphere volume type, custom volume type, and so on, with UI as well. So if this is something that you are using internally and there was something missing for you, let me know. Thanks for watching, and any feedback